everyone. My name is Eli Wu. Welcome to Computex. Okay, so in this session, we will be talking about the everywhere cloud, empowering the edge computing. So if you look deeper, closer to today's data center, it is easy to find out there are mainly two types of server dominate today's industry. The first one is the EIA server, and the second one is the 21-inch OCP servers. So the EIA servers has a universal standard that enable the vendors to design and develop their own product, their own servers. Also, this allowed the user to have the diversity options in the industry. On the other hand, in OCP community, the OCP community was introduced nearly 11 years ago by Facebook. It is emphasizing on the easy maintenance, also the modular design like DCSCM, and also the effective cost. So in GIGABYTE, we have both the EIA server and the OCP server. Some of our customers even buy both the GIGABYTE EIA and OCP server at the same time to deploy a heterogeneous computing pod in their data center. So let's look at the right. Today's data center is getting hotter and hotter. We all know that's because the TDP of CPU and GPU are getting hotter, right? Like today's Intel Sapphire Peak goes up to 350 watts, and Genoa from NND can goes up to 400 watts. Even the GPU is also getting higher and higher. Therefore, the conventional air cooling solution no longer aligned with today's ESG vision. So, GIGABYTE has introduced the advanced cooling solution like the liquid cooling direct-to-chip solution and the immersion cooling tank. Our tank is right over there in our booth. Feel free to take a look after the talk. Next, let's look at the theory of the cloud computing. So in theory, the user needs to connect to the internet. Once you are connected to the internet, you can enjoy all the benefit of the computing power, right? No matter it is for 5G scenarios or the AI smart factory or the CDN networking. Once the users are connected to the internet, this computing power can be provided. But is that really the case? Well, we're still facing some challenges in the scenario in the real world because the data centers are usually located in the rural area, and this will cause the latency. Besides that, in the rush hour when the demand is high, the limited bandwidth will have the bottleneck. Therefore, we need to deploy as many edge servers as possible in the edge location. Here, I can break down all the scenarios in the edge computing into 3 tiers based on the level of latency. The last one, let's look at the first one, the latency critical. The reason I put latency critical means this type of scenario requires the real-time response. Asynchronous computing, if the delays happen in this scenario, it might cause a negative effect in the outcome. Let's look at the middle one, the latency sensitive. Why is it sensitive? It means the latency is still important, but a relatively slightly higher response is tolerant. The most notable scenario in this category is the CDN networking, and we will be talking deeper about the CDN networking in the later slide. And the last one is the cloud data center. Of course, cloud data center plays a critical part in today's digital world. It is where we store all the data in the data center, whether it is structured data or unstructured data or the raw data. Also, in the data center, we can put the GIGABYTE GPU server locally in the cloud data center, so the GPU server can achieve loads raw data, structured data, unstructured data for AI, inference, or machine learning, and then to generate a conclusion, an answer, or a prediction, and then send those outcomes back to the edge. This slide illustrate that the Gigabyte has a really wide solution from the far edge, near edge to the data center. Okay, from the far edge, Gigabyte has the edge server. They emphasize on the small, compact size of the chassis. So the edge server can be deployed anywhere you need easily. Let's look at the near edge. The near edge, we have the rack series, the edge series. Edge stands for high density. So it can provide the highest CPU core count amount, also for financial trading or for web hosting. As for the data center, we have not only the storage server to keep hot cold data stored, we also have the GPU server for AI and machine learning. So this picture will give you a better understanding of the relationship between data center and edge location. So we all know that building a data center is not easy, right? It costs a lot of money to build that, and it is just not practical to build as many data centers as you want in the cities. Instead, we need to deploy the edge server close to the end user where the data is being generated. This will solve the latency issue, also will solve the bandwidth bottleneck. So in the later section, I will go through the Gigabyte's solution from the data center to the far edge. First, let's look at the data center. Like I said earlier, Gigabyte has both EIA solution and the OCP solution. So for the EIA server, we have the rack server for the general computing. As for the edge series, it's for the high density CPU core count, also for financial trading, web hosting. As for the GPU server, Gigabyte has been a critical leading partner in the AI industry. That's why our GPU server has been working closely with our partner like NVIDIA on the NVIDIA H100 series GPU. On the other hand, for the OCP solution, we create a hyper coverage OCP server. You can use this OCP server in your OCP rack for general computing or GPU. Now let's look at the far edge scenario. Remember, I said the near edge scenario. Remember the latency sensitivity represent that the slightly higher response time is tolerant. However, it still requires a quick response computing outcome from the computing node. The most notable scenario of this category is the CDN networking. For example, if you are the user sitting in your home and request a trending video, whether it is on YouTube or Netflix, you just click the request button, and then the computer will find the nearest edge server to deliver the requested content back to you, right? That is usually the case. But what if you are requesting a less trending, less popular data? That is not everyone's probably not be searched recently in the neighborhood. This time, the near edge location server will need to go back to the data center to retrieve the similar or the relative data from the data center and then deliver back to the end user. This is the reason why sometimes you require a less trending, a less popular video content. It takes a little longer time to process. But don't worry, Gigabyte's rack server has the ability to analyze all the data in the community. So once this content has been requested by the user or by the community, the server will remember it and then to retrieve the similar relative data stored locally in the edge server. So the next time when you are requesting the similar data, the relative data, the data has already been stored locally in the edge server. So the edge server can quickly deliver the content to you without any latency. So the CDN scenario emphasizes on the quick response time. That's why it is very important to deploy as many edge servers as possible in your network. Gigabyte's R162 and R163 series are emphasizing the short depth chassis design, so it is easy to be deployed anywhere in the community. Also, the latest generation, the R163 series, provide the fastest PCIe Gen 5 SSD speed. So the read and write speed data transfer will be even quicker. Now let's look at the far edge scenario, the latency critical. Remember, I put critical here is because this scenario requires the real-time synchronized computing response. If a delay happens in the process, it might cause a negative effect in the output. One of the most notable scenarios of the far edge is IoT scenario. IoT stands for Internet of Things. For example, you are the owner of an AI smart factory. You need to deploy the edge computer, the edge server close to the production line, right? What if something happened, like an error happened during the production line, and the computer cannot respond at the proper time? It might cause the whole product line to shut down. That's why the Gigabyte's Echo 162 edge server are ideal for IoT scenarios. It is short depth chassis design. Also, you can put a GPU for high flow length in such a small compact server. This GPU will provide the GPU rendering, image rendering at the front for you to enable the IoT and smart factory usage. Next, we have the 5G telecom scenario. And we all know today's 5G still needs to be more accessible and approachable, right? That is why our Echo 251 U70 has been chosen by the NVIDIA on their Aerial project. We provide the hardware for NVIDIA, and then NVIDIA designed the software for their Aerial development kit for vRAN technology to make 5G more accessible. Next, we have the Echo 252 P30. This is the Ampere ARM-based architecture CPU. So if your smartphone, whether it is Apple or Android phone, the chipset are all ARM-based chipset. So this server also uses the ARM architecture Ampere CPU. When your phone is trying to communicate with the server, it no longer needs the process for code transcoding. So it will save a lot of time and give you the synchronized computing response. Next, we have the Sienna platform. Sienna is from AMD's latest chipset, but I'm not able to disclose further information at this moment due to the NDA. But I can only tell you this CPU and this server will emphasize on the 5G telecom and the cost-effective scenarios. The last but not the least is the healthcare scenario. I specifically picked this scenario is because in today's data center, We all know how important it is to protect the personal data. That's why in Europe we have the GDPR. In California, we have the Personal Data Protection Act. That is why the protection of your personal digital footprint is critical. Especially, it is your medical history. That's why we have the Echo 263 for the edge GPU, CPU to GPU computing for the heavy surgery or for the medical study, data analysis, and when those processes are done, those data will be stored in the S251 server locally on-prem in your private cloud. Therefore, the data is being protected and saved on-prem in private cloud. Next, we also have the R283 series. This series provides a CPU to GPU performance. It is powered by two latest CPU from Intel and AMD. Also, it provides two full high-flow length GPU supported. So whether it's for data analysis or big data rendering, this server is ideal. So let's look at the power of the future. Like Johnson from NVIDIA says, AI is going to change the future. And it is not just about the future, it is changing the future now at this moment. This is why GIGABYTE has been emphasizing on the AI and machine learning industry with our GPU servers. Our GPU G293 and G493 servers emphasize on the PCIe type of GPU scenarios. It can host up to 8 to 10 PCIe full high full length GPU cards like A100, H100, H100 MVL, L40 for Omniverse, or the AMD's NI210. If you are looking for the best GPU to GPU communication, we also work with NVIDIA to promote our G593 series. You can see it's right here. This server is the first in the industry that can host up to 8 H100 DGX system in 5U form factor, in 5U. That is the best in the industry at the moment. If you are looking for a higher density in terms of the GPU computing power, our G593 will be the ideal server for you. Also, if you are looking for the Scout system from NVIDIA, we have the G363, also the AMD NI250 ONN module design. We have G262 in the market. The last, I would like to invite everyone to join GIGABYTE to empower the future together. In GIGABYTE, we have this module design. It is like the Lego design, the idea of Lego. We can custom your server based on your requirement, whether it is for the edge computing or the GPU expansion slot, that kind of requirement. You name it, we do it. Thank you.